Welcome to The Explainer. I'm absolutely thrilled you're here today. If you've ever been curious about the invisible engine powering the modern world's most fascinating tech, well, you're in exactly the right place. Today's Explainer is all about demystifying deep learning. We're going to break down this complex topic step by step using clear, simple explanations and some real-world examples. By the end of our time together, you'll have a rock-solid understanding of what really makes this technology tick. So, have you ever wondered about this? Imagine you show a computer thousands of pictures of cats and dogs. At first, it's completely confused, but after learning from millions of images, it suddenly recognizes a cat in just a fraction of a second. I mean, how is that even possible? The answer is deep learning. This is the exact same underlying technology powering things like ChatGPT, self-driving cars, face unlock on your phone, and even advanced medical analysis. But what exactly is it, and why is it so incredibly powerful? Let's find out. Okay, let's dive right in. Here's our agenda for today. First, a welcome to deep learning. Then we'll look inside a neural network, understand network layers, check out the power of GPUs, explore real-world AI applications, and finally, we'll compare deep learning versus machine learning.
Part 1. Welcome to Deep Learning Beyond Basic Rules.
To really appreciate this, remember that traditional computers rely on humans to write rigid, fixed rules. Deep learning totally flips that script. It's an advanced branch of machine learning that uses artificial neural networks to learn complex patterns directly from data. So instead of programmers mathematically defining a cat's ear triangles or whisker lengths, we literally just feed the system massive amounts of data, and it discovers those complex patterns entirely on its own. And this brilliantly illustrates the concept. Think of traditional machine learning as teaching a student by handing them a textbook. They read the rules, they memorize them, and they apply them. Deep learning, on the other hand, is like giving that student years of actual hands-on experience and millions of real-world examples. The more examples it sees, the sharper it gets. This is exactly why deep learning can understand images, interpret speech, read handwriting, and generate human-like text so flawlessly.
Part 2. Inside a neural network, inspired by the human brain.
To understand the architecture, we actually have to look at biology. Our brains contain billions of neurons connected in this vast web. Imagine you're walking down the street and you recognize a friend. In a split second, your biological neurons check their face shape, eyes, nose, hair, and finally, that familiar smile, combining all that data to shout, "Hey, that's my friend." A digital artificial neural network does the exact same thing. Each digital neuron receives information, performs a tiny calculation, and just passes it right on. Now think about the sheer scale of this. One single digital neuron alone, it just does a tiny piece of math. Not very impressive on its own, but when you connect millions of them together, communicating and passing calculations back and forth, they form a collective intelligence that can recognize faces, understand complex speech, and instantly translate languages. It's like a giant puzzle coming together.
Part 3. Understanding network layers, peeling the onion.
These millions of digital neurons aren't just thrown into a chaotic pile, right? They're arranged in highly organized structures called layers. Basically, every network is built on this specific structure. First, we have the input layer. This is the front door. It's where raw information, like the pixels of an image or the sound waves of a voice, enters the network. Next, we have the hidden layers. This is the engine room. It's where all the heavy lifting and analysis happens. And finally, we reach the output layer. This is the exit door that gives us the final answer, confidently stating, "This is a cat," or "This person is smiling." Let's see how this understanding actually builds as we move through those hidden layers. As raw data passes deeper into the network, the understanding compounds. The first layer spots simple edges. The next combines those edges into shapes. The next finds specific features, like eyes. And the final layers combine it all to detect a complete human face. This deep, progressive layering is exactly why we call it deep learning.
Part 4. The power of GPUs, why speed matters.
So why does speed matter? Well, this really comes down to the hardware. A normal computer processor, or CPU, is fantastic at handling one task after another. It's kind of like one brilliant student solving 1,000 math problems sequentially. It gets the job done, but it takes a lot of time. A GPU, or graphics processing unit, operates completely differently. It's like 1,000 students solving one math problem each simultaneously. Because deep learning requires billions of tiny calculations to be done all at once, it relies heavily on GPUs. Actually, here's a crazy fact. To train a massive model like ChatGPT, they didn't just use one GPU. They used clusters of tens of thousands of them running simultaneously for months.
Part 5. real-world AI applications, sight and sound.
Because this tech learns from data rather than fixed rules, it's incredibly versatile in the real world. Let's look at image recognition first. By training models with millions of labeled pictures, they literally learn to see. This is why Face Unlocked on your smartphone works so securely. It's how AI can assist doctors by analyzing medical x-rays for anomalies way faster than the human eye. It's used in factories to instantly spot tiny defects on products moving down an assembly line. And, of course, it's what allows self-driving cars to differentiate between a pedestrian, a stop sign, and another vehicle in real time.
But beyond sight, there's sound. Deep learning gives computers the ability to truly understand speech. When you talk to your smart speaker, deep learning models are instantly converting your spoken audio waves into text, understanding the intent behind your request, and generating a helpful response. It powers voice assistants, the voice typing feature on your keyboard, live closed caption on videos, and even real-time language translation. It's everywhere.
Part 6. Deep learning versus machine learning, the ultimate showdown.
These two terms are often used interchangeably, but they are very different. The crucial point here is the level of manual hand-holding required. Machine learning typically learns from neatly structured data, think spreadsheets, and it requires humans to manually point out important features. Deep learning, however, dives directly into messy, raw data like audio files and automatically discovers the important features entirely on its own. While machine learning is great for simpler problems on standard computers, deep learning is the heavyweight champion for complex vision and speech, demanding those massive GPU clusters we talked about.
All right, let's recap what we've accomplished in today's explainer. We've learned that deep learning is a highly advanced branch of machine learning. It operates using artificial neural networks that are beautifully inspired by the biological design of the human brain. We saw how it processes raw data by pushing it through an input layer, letting the hidden layers find the complex patterns, and delivering an answer through the output layer. We learned that it absolutely relies on GPUs to crunch billions of parallel calculations at lightning speed. And finally, we saw how it powers the modern marvels of image and voice recognition we use every single day. I want to leave you with this core thought to help you remember everything we've talked about today. Machine learning is learning from a guidebook. It's solid, it's reliable, but it certainly has its limits. Deep learning is learning through years of rich, complex, messy experience. It's dynamic, it's deep, and it gets exponentially better the more it interacts with the world. And that brings us to the end of our journey today. Now that you understand the incredible mechanics behind how machines can actually learn from experience, what complex problems do you think this technology could solve next? The possibilities are truly endless. Thank you so much for joining me for this explainer. I hope you found it insightful, clearly structured, and most importantly, that you learned something new today. Keep wondering, keep exploring, and keep learning. I'll see you in the next one.